I want this one to be blue and I want this one to be red. Oops. Okay, that'll be a little bit more similar to what we have on our paper. Okay, so the blue ones match up. Those are the same. That vertex is at the point 3, -2. So if I like click on it here, 2, 3, -2, I also could recognize that the vertex is indicated right here. So at 3, -2, I'm going to have a point. And then this one has greater than or equal to. So I'm going to draw solid lines up. I'm going to try to make this a little bit accurate. So it's going to intersect at 1, 0, and 5, 0. So let's see. This should be 3. So 2, 1, 4, 5, negative, oops. So -1 and then -2. Okay, so my absolute value should go through there and should go through there. And since this is everything bigger than or equal to, we're going to shade in everything above that absolute value. Okay. Then for our pink graph, its vertex is going to be up here at 2, 4. So let me mark 4 marks up here. So 1, 2, 3, 4. Okay, so at 2, 4, I should have my vertex. All right, and then let me unhighlight these guys. Oops. So that we don't have so many dots in the way. These x-intercepts are going to be at -2, 0, and 6, 0. So -2, 0, and then 6. So it's going to be a dashed line because it's just strictly less than. And then this is going to pass through 6. All right, and then everything below this is going to be shaded. Now the solutions here are going to be where the pink and the blue overlap. So this little section in here is where our solutions are going to be. Okay. Now the intersection points of these two graphs here and there are not solutions. Okay. So those two are not solutions, but any point inside of this little diamond shape here will be. Okay, so they're going to be, so let's write out a little thing for our solutions. So we're going to have infinitely many solutions. There are infinitely many little points that could be in here. Because not all of them have to be integer values. We could have like 1.1, 1.1, 1.2, 1.1, 1.3, 1.1. So there are infinitely many places we could put points inside of here, right? An example of a solution would be the point, let's see, this is 1.21 is definitely inside of there. 2 is a solution, even 2, 2 should be a solution. Okay, and you can look at this on Desmos. 2, 1 is right here, 2, 2 is right there. They're both in this overlap. Okay, so that's our first example. What questions do you guys have about that?
Could you scoot it up?
Yeah. So those dots are not solutions, but this stuff are the solutions. Okay, so any other questions? I forgot my other parenthesis around the second solution. Okay, when you're ready, we're going to go ahead and do another one. So I'm going to flip my paper over. Does anybody still need this to copy down? Okay. It sounds like nobody is in need of this page still, so I'm gonna flip it. Okay, and I'm gonna make my screen big again so that we can do this together. It's a little bit easier to see. So in our second example, I'm gonna have the value or the inequalities. Said all the wrong things before I got the right thing. X minus 3, the absolute value of x minus 3 minus 2. And then the inequality y is greater than x plus 9 minus 5. So this is our system of inequalities right here. Again, I'm going to make my top one blue and my bottom one pink. And I'm going to sketch out a graph. We need more on the left than we do on the right. I'm going to extend it out a little bit. Okay. So let me make this a little bit smaller and I'll go ahead and start typing in our functions into Desmos. Okay, so our first one is going to be x minus, oh, look at that, that one's the same. And then our next one is going to be greater than, and then x plus 9 minus 5. Okay, so these are our two functions. Oops, let me zoom out so you guys can see it. So our two vertices, for our blue, it should be at 3, -2. Okay, so I guess I should put marks in there. 1, 2, 3, and then -2. My other one's going to be at -9. -9, -5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 3, 4, 5. I'll extend this down. Okay, so that was at 9, -5. This one is at 3, -2. Okay, and the blue one is going to have a solid line because we have a greater than or equal to. And I'm just gonna sketch out for this one. My x-intercepts are probably not accurate. And then for this one, I'll have something like that. And then something like this. I'm not going to extend it out all the way. And this one will have everything shaded up here. This one will have everything shaded here. And the overlap is going to be infinite and it's going to extend out all the way up. Okay. So this point right here is not a solution because we have a dash intersecting with a solid. But then all of this stuff over here will be solutions. Okay, so maybe this problem asks you to name 4 solutions. Okay, so you can just look for anything in that purple overlap. So we could do 0, 10. Let me call in somebody to see where you guys are at with this. Peyton, can you give me a solution? Peyton, are you there? Well, Peyton disappeared. Nikaya, could you give me a solution?
I didn't disappear. I'm right here.
Oh, okay, great. Can you give me a solution, please?
For what?
So solution could be in this purple region, any point within this purple region. You could give me.
I can't hear you. It's breaking up.
Okay, so solutions, remember, are on the overlap of the two functions. So this purple section, can you give me a point in the purple section?
I'm sorry, miss. I really can't hear you. It sounds like you underwater.
Can you give me a point in the purple section? Okay, I'm gonna message you and then you can message me back with a solution. Nikaya, if you're there, could you give me a solution?
Okay. So all I gotta do is look where in between they
Yep.
cross.
Yep.
All right. Hold on. Probably like 0 and 2.
So 0, 1. So that one's right on the dashed line. So that's at 4. So at 0, 2, it's right here. That's only in the blue. So we gotta have something in the purple. So go a little further up.
Well, is 0, 4 okay? Because I was doing it on a computer.
So 0, 4 is right here, and that's on the dashed line, and the dashed line is not included. So up a little bit more.
0, 5.
Yeah, so 0, 5 works. Very good. Okay, and then I'll give you a few more examples while we're waiting on Peyton's. Let's see, we could have -5, 10 would work. 3, 10. Peyton says 0, 6. 0, 6 works. Okay, so there are infinitely many of these. If I said name 4, maybe pick like these 4 or something like that, or the last 4, whatever you want, but any of those would work. I have one more little concept that I want to go over before you guys are done. So our last example is going to be an example where we have no solutions for a system. Okay, so an example with no solutions, maybe y is greater than or equal to the absolute value of x plus 5, and y is less than the negative absolute value of x minus 5 plus 5. Okay, so maybe this is our system. Let me, I don't know if I have time to do all this. I'm not going to graph it in Desmos this time just for time's sake. But we would have one absolute value function with a vertex at -5. We would have another absolute value function with a vertex at 5, 5. Okay, and both of them, so this one will be dashed because it's just a less than. This one will be solid. Okay, and do you guys see how they will never intersect? So we have stuff up here, stuff down there, but they never overlap. Okay, so this is an example where we have no solutions. What questions do you guys have about that? About either one. I didn't take questions on the last one. I apologize.
I missed the whole thing because your screen was doing something. I don't know what it was doing. But
Okay, well, I will post the solution or the video to all this. So just go back and rewatch it. Are there any, glancing at it, is there anything that doesn't make sense? Okay, any questions generally about this concept, finding solutions for inequalities?